So, hello and welcome. So, in this class today we are going to learn about application of Coulomb's law, like when two or more than two charges are present. In that case, what will be the net force acting on the charged particles? All these things we are going to learn in today's class. Okay. So let us continue. So what we have learned till now, that is electric charges, what are the methods of charging, then Coulomb's law and its vector form, and then superposition principle. So let us quickly recap what we had seen till now. So we had seen Coulomb's law, that is force acting between the two charged particles. So that will be equals to k q1 q2 by r square, where k is what, constant, and its value is how much, 9 into 10 to the power 9 unit. If you don't remember, no need to worry. From here we can find the unit. Force is Newton, Q1, Q2 is Coulomb, R is distance. So from there you can find the unit. Now K is equals to 1 upon 4 pi epsilon naught. Here epsilon naught is called as permittivity of free space. And its value is, we can roughly remember as 9 into 10 to the power minus 12. So this value we can put and we can find the value of K. Now, after that, we had seen Coulomb's law in vector form, because we know force is a vector quantity. So, Coulomb's law in vector form, we can write, suppose there are two charged particles and we consider charged particles as Q1 and Q2. So, force will be equals to K Q1 Q2 by RQ R vector, or we can write K Q1 Q2 R cap by R square, like this. So, next is superposition principle. All these things we have studied in previous class. So superposition principle is when two or more than two charges are present. So net force acting on the charged particle, that will be equals to vector sum of all the forces that is acting due to each charged particles. Simple, easy. Let us solve one question based on this concept. So question says that four bodies of equal charges Q are placed at the corners of a square of side A and one charge at the center of the square as shown. So we have to find force exerted by the other charges on the charge placed at the center. So on this charge, the charge which is at center, how much force is acting, that we have to find, right? So what we should do, can I say that the separation between all the charges from this center charge means this distance, let us say x, 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 all these are what? Same distance. Magnitude of charges plus q plus q plus q plus q and so on. So can I say that their separation is same and their charge is also same. So we can say that due to one charge, force will be how much? Due to, if I consider this is charge 1, 2, 3, 4. So due to first charge, positive charge, like charges repel. So let us say F1. Due to second charge, again repulsion. So F2. Due to third charge, again repulsion, that is F3. Due to fourth charge, again F4. So all the forces are like this. Now since if I write force due to one charge, that will be equals to K Q1 Q2 divided by R square. Here R is how much? Can I say R will be equals to half of diagonal? So diagonal is A root 2 divided by 2, that is equals to A by root 2, and all the forces are equal. So can I say that force F1 will be equals to F2, that is equals to F3, and that is equals to F4, which are equals to F only. So since all the forces are equal, so F net will be how much? F net will be equals to 0. So net force acting on the charged particle placed at the center, in this case will be how much? 0. Simple, easy. So F1, F2, F3, F4 both are, all are equal. So F is k q square by root 2 a by 2, that is separation between the central charge and the corner charge. So net force will be how much? 0. Simple. Let us solve next question. And all of you, please pause your screen and then try to solve by yourself. Once you try by yourself, then only you can learn it easily. So question says that four particles A, B, C, D having charges plus Q minus Q and plus Q respectively are placed on the vertices of a square having side of length L. So find the resultant electrostatic force acting on the particle C. So on this charged particle, how much resultant force is acting, that we have to find, right? So what we should do? So here let us say this D charge and this C charge is plus minus. So force due to D charge will be in upward direction. Let us say F1. Now due to B charge again, force will be in this direction. Let us say F2. Now if you consider B and D charges, so their magnitude is same and separation from C is same also, right? So can I say F1 and F2 will be same? Now due to A charge, it will be in this direction, right? So we can break the charges force along x-axis and y-axis. So can I say that force due to charge at B, that will be equals to force at charge at D, that will be equals to, let us say, F, which is equals to K Q square divided by R. R is how much? A. So A square K Q1 Q2 by R square. Similarly, can I say that force due to charge particle at A, that will be equals to, let us say, this is F3. So F due to A, that will be equals to K Q square divided by, now separation is how much? Diagonal. So A root 2. So A root 2 square is 2A square. So this is force due to charge particle at A. Now we want to write in vector form. So in vector form, can I say that F1 is along y-axis as given in the diagram, y-axis, x-axis. F2 is along minus x-axis. So if I want to write, and this F3 we can break in two parts. F3, can I say this equal to how much? This was kq square by a square. So can I say this is nothing but f by 2? Yes or no? So in this direction again we have f by 2, and in this direction also again we have f by 2 if f3 is equals to f, right? Sorry, f by f cos 60. So f by 2 root 2. F cos f by 2 cos theta, no? Cos 45 degree. And here also f by cos 45 degree. So f by 2 root 2. Is it clear, everyone? This is f. So in this direction this was f by 2. So in this direction it will be how much? F by 2 cos theta. In this direction also it will be how much? F by 2 cos theta. So we can put the values, right? So can I say that force along x-axis, that will be equals to f plus f by 2 root 2, and it is in negative direction, so minus sign. Similarly we can say force along y, that will be equals to f plus f by 2 root 2, and both are in upward direction, so positive sign. So from here, and f is how much? K q1 q2 by a square. So from here now can I say that correct answer will be f. If we take common, so 2 root 2 plus 1 by 2 root 2 minus I cap plus j cap. By sign also easily we can answer, no need to do the calculation. By sign also directly we can answer this question, right? So here we have to use the principle of superposition of electrostatic force. So we can solve force along x-axis. So this force we can break along x-axis and along y-axis, and we can simplify. So force net is force along x plus force along y, and simplify this. Clear? Simple, easy. Now, so correct answer is A, as we had solved. Now next question, let us move forward. So next question is, three identical particles of equal charge plus q are placed at the corner of a regular hexagon of side A as shown in the diagram. Net electrostatic force on plus q, which is placed at centroid, will be how much? So here we have three charge particle. Since it is a hexagon, so can I say that all these distances will be how much? Equal to the side, and in this case side is given as A. So this will also be how much? A. This will also be how much? A. And this distance is also equal to how much? A. Right? So here now if I want to write, so positive charge, force, one force in this direction, again magnitude will be same, one force in this direction and one force in this direction. So we have three forces, and angle between them is how much? Equilateral triangle. So this angle will be how much? 60 degree and 60 degree. So we have three force. One force is like this. Another force at angle of 60 degree. this angle is 60 degree, and again one more force at angle of 60 degree, right? So now if I break these two forces which are at some angle, so it will be how much? F sine 60, so F sine 60, F sine 60 degree. Again in this case also in vertical direction it will be how much? F sine 60 degree. In horizontal direction both components, so plus 2F cos 60 degree. Cos 60 is how much? 1 by 2. So cos 60 and this we can cancel. So this will become how much? Equals to 2F. And here F is how much? F is equals to K Q square divided by A square. So we can write the final answer is how much? 2K Q square by A square. Simple, easy, right? So once we understand the concepts of this electrostatics, this is very simple topic and questions are asked from these topics. So three charge particles are there. Again here multiple charge particles are there. So we have to use principle of superposition for electrostatics, and we can find the electric force due to all the three charges, and we have to do the vector addition what we had done, right? So F net will be equals to twice of K Q square by A square. Simple, easy. So correct answer will be C. Now, next is some general term we can say, or standard kind of questions. Consider the situation given below. So what is the net force on the charge at the center? So in this case we have one regular pentagon in which charge particles are there at all the corners of the pentagon, and if I place one charge particle, now this central charge particle's magnitude can be same or it can be different, but the charge particles which are at the corners, these charge particles must be symmetric, their value should be same. In that case, net force on this charge will be how much? F net will be equals to 0. Similarly, in case of a hexagon, if charge particles at the corners, all these six charge particles are identical in magnitude as well as nature, plus sign or minus sign, and one charge particle is at center, this charge particle can have different value also. In that case, net force again is how much? F net will be equals to how much? 0 only, right? Simple, easy. Now, next is again let us solve one question. Question says that like this, we have a clock. So consider question here we have 12 charged particles, and charged particles are like at one charged particle is 1 coulomb, 2 coulomb, 3, 4, 5, 6, and so on up to 12 coulomb. These are all coulomb, right? So like this we have charged particles and we want to find the uh, net force at the charged particle which is placed at the center, and of course distance of all the charged particles from this central charge is how much? C. So now in this case how to solve the question? It looks bit complicated, but if you see carefully, so can I say that if I consider 1 coulomb, and here we have opposited this 1 coulomb, here we have 7 coulomb. So due to 1 coulomb force will be, let us say, F. So due to 7 coulomb force will be how much? 7F, right? Similarly due to second and 8, so we have like this angle will be, we can divide 30 degree, right? Similarly for fourth, fifth charge, sixth charge, right? So we can draw it properly. So here due to all the charges, if I consider net charge, so due to 7 and 1, one simple. So due to 7, net force in this direction is, we can say, 7F, means K Q1 Q2 by R square, so that will be 7F if we consider K Q1 Q2 by R square as F. So net is how much? 6F, right? Similarly for this one, all we can simplify. So if I consider this 6F as F, so F is here, they have considered 6 times K Q1 Q2 by R square. Q1 Q2 is 1 only, so 1 square it will become F. So here we have a total 6 charge, 6 forces, F, like this. Angle we can see between them. So we can break them along x-axis and y-axis, and then we can simplify. So just break all of them along x-axis and y-axis, and then we can add them. So if you break along x-axis and y-axis, so due to these two forces, their vertical components gets cancelled, and the only horizontal component of these two upper charges and do these two forces, they will add up. So we have F plus 2F cos 30 degree plus 2F cos 60 degree and one vertical force. So we can simplify. So net force will be how much? 2 plus root 3F I cap plus F j cap, where F is how much? F we considered as 6 k by a square. Q1 Q2 is 1. Simple, easy. See, let us see one more time. We had 12 charges, and at 1 it is 1 coulomb, 2 it is 2 coulomb, 3 it is 3 coulomb. So in front of charges we can simplify. So 7 coulomb and 1 coulomb. So effective is how much? 6 coulomb. Like that we can simplify, and we can find the net force. Right? Now let us move forward. Let us solve one more question. Now this question all of you have to solve. Question says that three charged particles ABC with charge plus minus q plus q and plus q are present on the vertices of an equilateral triangle having side of length A as shown. So find the magnitude of the resultant electrostatic force on the particle A. So here net force is how much that we have to find. So in this case again, can I say that due to charge B and charge C, since separation is same, so force acting will be how much? F and F, yes or no? So now we have two vectors F and F, angle between them is 60 degree. So can I say that F net will be equals to how much? F net will be equals to root under of F square plus F square plus 2F cos 60 degree. Cos 60 is 1 by 2, so 2 gets cancelled and we can simplify this. So this will become how much? Root under, sorry, F1, F2, no? So F square. So it will become how much? 3 root 3 F square. And F is how much? Here F will be equals to K Q1 Q2 divided by A square, and Q1 Q2 is Q only. So this will become how much? K q square divided by a square root 3. So from here if I want to check the answer will be which one? A. Simple, easy question. So again we have to use the superposition principle, so we can find the force due to all the charged particles and then we can simplify. So answer is how much? Root 3 kq square by a square. Simple, answer is A. Now next is, again let us solve one more question. Question says that, now it is a good question. Why we say good question is when more than one concepts are used in a question, then that question is good question. So if a point charge q1 is fixed at a and a point charge q2 is released at a distance r1 from q1 as shown, so find the velocity of q2 when it reaches a distance r2. So here we have two charged particles q1 and q2. q1 is fixed and q2 we have released from r1. So when it reaches r2, same charge, so they will repel each other. So when it reaches at this point, so how much is find the velocity of q2 when it reaches at this point. So this we have to find. Okay. So in this case, what we have to do is this question we can solve by two methods. One is once we study the electric potential, then we can solve this by potential method also. But in this case, let us solve by force method. In force method, what we can do is here how much force was acting, and as it moves forward, so force is changing, so we can write in terms of force and displacement to solve this question. So let us say that we consider one random point when the particle was at a distance of x, right? So here some force will be acting, charge is q2. So here now can I say that when particle is at distance x, when particle is at x, so here force will be equal to how much? K q1 q2 divided by x square, right? Now we want to find velocity. So force can I write as mass times acceleration, and mass of the charged particle is, we can say force is what, mass times acceleration, that will be equals to k q1 q2 divided by x square. Yes or no? Now acceleration can I write as v dv by dx. Any problem in this? We can write acceleration like this. So that will be equals to, now mass we can move on right side. So we have k q1 q2 divided by m times x square. Right? Now simplify this. Very simple. So here now we have v dv, that will be equals to k q1 q2 divided by m. These terms are constant, and we have dx by x square. Integration is from r1 to r2, and this one is integration from 0 to v. Right? Simple. So now acceleration of v dv will be equals to how much? So v dv is v square by 2. So that will be equals to k q1 q2 divided by m. Now integration of 1 by x square dx, that will be how much? 1 by x square dx is minus 1 by x from r1 to r2. Yes or no? So if you remove this minus sign, this will become how much? 1 by x from r2 to r1. So this will become how much? 1 by r1 minus 1 by r2. So from here now simplified, 2 will move on right side. So v will be equals to root under of 2 k q1 q2 divided by m into 1 by r1 minus 1 by r2. This will be our answer. Bit lengthy, but it's good question and simple. Once we study potential energy concept, then we can just apply the energy conservation k q1 q2 by r, that is equals to half mv square, and we can easily find the answer. Right? Simple. So this is solution v dv k q1 q2 by mx square dx. So we can simplify just only this point. If you are able to write one general term at point x, how much is force, and force is mass times acceleration. Acceleration is equals to v dv by dx, and then we can simplify and we can easily answer. Right? Next, let us solve one more question. Now question says that we have two blocks carrying charges q1 and q2 are placed at a distance L. If the mass of q2 is m, so this mass is m, and the coefficient of friction between the block and platform is mu, then find q2 such that the block 2 just starts to move. So we have to find the magnitude of charge q2 so that it will just start moving on this surface. So can I say that if this block is just about to move, let us say that charge q2 is positive, then direction of friction will be in backward direction because force will be acting in forward direction. Yes or no? And friction and this force should be equal. So just about to move, so can I say that force should be, or friction is less than equals to F max. Here force acting is how much? F is equals to K Q1 Q2 divided by L square, right? So now this force is how much? K Q1 Q2 divided by L square, that will be less than equal to how much? Mu times mg. So from here now, can I say that if you simplify, so Q2 will be equals to mu times mg into L square divided by k into q1. So if we use the inequality sign, so it will be less than, so q2 should be this value. So the minimum value at which this block will start moving, sorry, so that will be equals to mu mg into L square by k q1. Simple. So force acting is k q1 q2 by L square. For charge q2 to be at rest, F should be equals to less than equal to F max. F is how much? K q1 q2 by L square should be less than mu mg, and we can simplify, right? So if q2 is positive, then its value should lie between this quantity, and if it is negative, then again just reverse the quantity, and we can simplify, right? Now, next is called as electrostatic equilibrium. So, name itself suggests electrostatic equilibrium. That means net force on the particle should be zero. So, the point where the resultant force on a charged particle becomes zero is called as equilibrium position, right? So, consider a charge which is initially in equilibrium and is now displaced by the small distance and release. So when we release, how to check the stable or unstable equilibrium? If you remember the work power energy concept, so we say that if you displace one particle by a small displacement and it moves away, that means the stable equilibrium was what? Unstable. If it returns back to its original condition, then it is what? A stable equilibrium. If it remains whatever position we leave, so that means what? Neutral equilibrium. So if we displace the charged particle from initial condition and it tries to return to the same equilibrium position, then it is called as what? A stable equilibrium position. If the charge has no tendency to return, means it moves away, goes away, gets away from it, then it is called as unstable equilibrium. And after displacing, if it is still it is in equilibrium position, means whatever position we leave, it is still in equilibrium. F net is zero only. That means it is called as what? Neutral equilibrium. Simple. Now, let us solve some questions on this concept. So, 2 point charges Q and 4Q are separated by a distance L as shown. Where should a third charge Q be placed so that it is in equilibrium position? So, let us say that now in this case we have two charge particles. One is Q, another one is plus 4Q. And we want to place one charge particle in between them so that it remains at equilibrium. That means suppose I place this charge particle here, and let us say the charge on this charge particle is capital Q. So if it is at equilibrium, that means net force on this charge particle should be zero, right? Let us say it is at a distance of x from charge Q. So then this distance will be how much? L minus x. Simple, easy. Now since let us say all these charges are positive only, so due to this charge it will be in this direction F1, and this is what? F2. Now if net force is 0, so can I say that F1 should be equals to how much? F2. F1 is how much? F1 will be K Q Q divided by x square, that should be equals to K. Now Q is how much? 4Q Q divided by L minus x square. Now K, Q, Q, common terms easily cancel every time. So we have now 1 by x square, that is equals to 4 by L minus x square. Now if you go by simplifying this term, it will become bit lengthy. So what we can do is take root on both sides. If I take root, this will become how much? 1 by x. This will save time, right? So this will become how much? 2 by L minus x. So now simplify. So this will become L minus x, that will be equals to 2x. So we have x that will be equals to how much? L by 3. So we have to place this charge particle at a distance L by 3 from Q charge, or can I say that it will be 2L by 3 from 4Q charge to place it at equilibrium position. Simple. So just equate the forces and we can simplify, and x will be equals to how much? L by 3, that we have solved. Now let us solve one more question. Question is, a charged particle Q is placed at the center of a line joining two particles of equal charge Q. The system of three charges thus defined will be in equilibrium if Q is how much? Now in this case, see, when we place the charge Q in between these two charges, so complete system is at rest, right? So in this case, they are asking what should be the value of this charge particle. This Q should be how much? right? So in this case, uh, can I say that net force on this charged particle is zero, as well as on this charged particle is also zero. So if I write net force, so due to this capital Q, net force will be, let us say, F1, and due to a small q, it must be in opposite direction, otherwise it cannot be at rest, this charged particle, right? So can I say that F1 should be equals to F2? So F1 is how much? K q square divided by, separation was L square, that will be equals to, second case is distance is L by 2, so K q divided by L by 2 square. So can I write L square by 4? So this will go up. So q Q we can cancel, L square also we can cancel. So from here now we have a q that will be equals to q by 4. Now q by 4, this is plus or minus. So see here, if we consider capital Q charges as positive charge, so this Q should be negative. So charge Q is placed center of joining two charged particles Q. The system three charge will be in equilibrium. So here, since sign is not given, so this capital Q we consider as plus charge. So this small q should be negative. That's why direction of force we have considered as attractive. Yes or no? Or if you consider positive, then F1 plus F2 should be equal to 0. From here, you will get the negative sign. Means our assumption is opposite. In this case, our assumption is correct. That means it is minus q by 4. Right? Not clear? Clear? So in this case, again, net force should be equal to 0. So kq by 4 pi epsilon naught L by 2 square. This term is nothing but 1 by this is nothing but k only. So you get the value as minus q by 4. Answer is D. Let us solve one more question. This is good question again. Question is, 2 point charges Q are separated by a distance 2L as shown. If a third charge Q of mass M as shown is slightly displaced along the line joining the two charged particles and released, find the time period of oscillation of this charged particle. So this difference, separation was 2L. This is mirror image they have given. So 2L, and this distance is L. Now here we have placed one charge particle. So by symmetry, can I say that this charge particle is at rest, net force was 0. Now if I displace this by a small distance x, so let us say particle is now here. So this distance is now how much? L minus x, and this will become how much? L plus x. Yes or no? So from here now we can find the F net, and direction of force is, due to this it will be in this direction and in this direction. So F1 minus F2, right? So we can write F net, that will be equals to F1 minus F2. So F1 is how much? K Q divided by L plus x square minus K Q divided by L minus x square, like this, right? Now if you simplify this, we will have L plus x square into L minus x square. So we can write it as K Q we can take as common. So Q we have common. So now we have L square plus x square minus 2 Lx, this term, minus now this term. So L square minus x square minus 2Lx divided by L plus x square into L minus x square. Like this we can write. Yes or no? Now here see, this L square x square, L square x square we can cancel. So now we know that L is very large compared to x. So in this case x we can neglect. So this will become how much? L square into L square, L to the power 4. So we have now K Q divided by L to the power 4, and this is how much? Minus sign is there, so minus 4lx. So L again we can, 1L we can cancel. So we have minus of k q q divided by LQ. 4 is there, so let us write 4KQQ by LQ into X. Right? Now this term, can I say that approximately equals to minus of omega square X? Similar format? Yes or no? So we have now, this is F net. So M A, that is equals to this value we got, minus of 4K QQ divided by LQ. If I move M on right side, so MLQ into X. This is nothing but approximately equals to minus of omega square X. So this term is how much? Omega. So what they are asking is time period. So we know that time period is what? 2 t equals to 2 pi by omega. So we can put the value. Simple, easy. So F net we can simplify. So this is our F net. F net. So acceleration is minus of this value into X. Acceleration for SHM we know is equals to minus of omega square X. So from here we can write time period, that is 2 pi by omega. Simple, easy, right? Now, let us see force on a charge in a medium. So till this point, I have tried to cover all the important questions, whichever is important, or variety of questions based on the Coulomb's law, right? Now, next is force on a charge in a medium. So if I place two charged particles in a medium, in 2024 also one question was asked that if two charged particles are in the medium, so force acting on each charged particle due to each other in medium is how much? So whenever I say due to each other, then charge force will be same only. But if I consider net force, then what happens is, see, in between there are medium, they gets polarized. So due to polarization, F net will be, this F induced will be there, due to which F net will change. But if I consider only due to each other, then it is constant only. Hope it is clear. So F net in this case is 1 upon 4 pi epsilon naught Q1 Q2 by R square. Epsilon R is called as relative permittivity of the medium, right? So this is all from today's video, means in this video. In next class we will continue further like electric charge, how to find electric field, all these things. So thanks for watching everyone, and feedback suggestions are always welcome. Thank you everyone. Bye bye. Take care.